Prove that the limit as x goes to 1 of the function 2x plus 1 is equal to 3. So what we're going to do is we're going to write our function f of x as 2x plus 1. We are approaching 1 on the x-axis, and when we do, the function itself is approaching this limit 2 times 1 plus 1, which is 3. So let's look at what's happening on the graph. Let's put an interval around 3 on the y-axis. And then let's project to the graph. And then project down to the x-axis. So now we have an interval around 1 on the x-axis. And if we were to choose any x value inside this interval and then project to the graph and then over to the y-axis, we would be inside of the interval that we made on the y-axis. And this interval is centered at 3. It's the same distance from 3 to the top of the interval as it is from 3 to the bottom of this interval. Now, this interval around 3 on the y-axis, we're going to call epsilon on either side. So it would be a distance of epsilon from 3 to the top of that interval and a distance of epsilon from 3 to the bottom of that interval. And then on the bottom down here at the x-axis, that will be delta on either side. So therefore, we could say that for any x value inside that interval, we would be within delta of 1. Or in other words, our c value. And then for any one of those x values projecting up to the y-axis, we would be within epsilon of f of x. Okay, so hopefully the visual is making sense. Now, how do we do this? What we have to do is show that for every epsilon greater than 0, there exists delta greater than 0 such that 0 less than the absolute value of x minus c less than delta implies that the absolute value of f of x minus L is less than epsilon. So in other words, if the distance between any x value and c, and in this case c is 1, less than delta, implies that the function value corresponding to that x value minus the limit is less than epsilon. So how do we do this? So we'll begin by saying, let epsilon be greater than 0. Then what does the absolute value of f of x minus L less than epsilon lead us to algebraically? Well, let's see. F of x is 2x plus 1, and L is 3. So if that is less than epsilon, then the absolute value of 2x plus 1 minus 3 is less than epsilon, just removing parentheses, which implies then that the absolute value of 2x minus 2 is less than epsilon. We could factor a 2 out of that, and we'd have 2 times x minus 1 is less than epsilon. And then we could pull that 2 out of the absolute values, and we'd have 2 times the absolute value of x minus 1 is less than epsilon. And then we could divide both sides by 2. And we'd have the absolute value of x minus 1 is less than epsilon over 2. Now let's stop for a second and think about why we just did what we did. Remember that our c value is 1. That's this one here. That is this one here on the x-axis. Now the slope of this line is 2. So it makes sense that our interval down here on the x-axis, in other words, our run, would be half of the interval up here on the y-axis, or the rise, if we think of slope in terms of rise over run. So, to finish this then, what we should say then is to let delta, our interval down here on the x-axis, be equal to half of our interval up on the y-axis. And how we say this is that we have found a delta that works. Okay, what does that mean? Well, now we have to write out our proof. So here's our proof. So we start with 0 less than the absolute value of x minus 1 less than delta. We multiply both sides by 2. So then we would have 2 times the absolute value of x minus 1 less than 2 delta. Now this then would imply that the absolute value of 2 times x minus 1 is less than 2 delta. In other words, we can pass the 2 inside of the absolute values. It's a positive number. It's not making any difference. This would imply that the absolute value of 2x minus 2, just multiplying that out on the inside, is less than 2 delta. Now, 2x minus 2. Now remember that the limit is 3, so we could write this, that's inside parentheses here, as the absolute value of 2x plus 1, there's our function, minus 3, less than 2 delta. Now, let's see. So now we can say that the absolute value of 2x plus 1, I'm going to put that in parentheses, minus 3, is less than 2 times epsilon over 2. Now, why would I do that? Well, that's what we chose delta to be equal to. We chose delta to be epsilon over 2. So, this implies, then, that the absolute value of 2x plus 1 is f of x, minus the limiting value, 3, is less than epsilon. This could also be stated if we choose delta equal to epsilon over 2, then for all x satisfying zero less than absolute value of x minus 1 less than delta, the inequality absolute value of 2x plus 1 minus 3 less than epsilon holds.